Hi there again. So today we're going to look behind this card here. Now, before I actually start the lecture, I want to talk a little bit about the lab because this week's lab is going to be the first in a four-part series of labs. And in that series, what we will be doing is rolling out a React app. And at the end of the 4 weeks, we'll have a fairly rich application, and you will be submitting that as your lab work for this module, and I'll be assessing it, and it'll be worth 40%. Also, once you've completed that four-part series, the app that you have will be the starting point for the assignment for this module. So overall, it's pretty significant. Now, the app itself, I can just give you a quick demo of it if I switch over to my VS Code. So I've got the completed app loaded in, and I'm just going to start up my Vite server. So this app is using an open API called TMDB, which stands for the movie database. And as the name suggests, the API provides loads of very much up-to-date information on everything to do with movies, TV series, actors, etc., etc. So what we can see here is the home page for our app. So you'll have this at the end of the 4 weeks. So it's showing us some current movies, about 20 of them in total, although there are more. And if we go to any one of the movies, there's a more info link here that gives us a little bit more information on that movie. Also on the top right here, I have a floating action button, which clicked will show me excerpts from reviews that have been written on the movie. And if I click the more info on any one of these, then I get the full review. I go back to my landing page or my home page. We have a filtering capability on this list of movies. So if I again select this floating action button on the top right, it opens up this slide sheet as it's referred to in Material UI. So I can filter on the basis of genres. So let's pick randomly, really, anyone. And so it just filters out movies associated with that genre. Again, I can get more info on that movie. As well, what I can do is I can select particular movies as my favorites, Maria. So, and you do that by clicking the heart icon here. So let's select this one and this one and this one. You can see the confirmation here on the top of the card for those that I've selected. And also I've got a favorites page over here on the right in my header hyperlinks. So this page just shows me my favorites, and I can write a review on any of my favorites by clicking this icon here, fill out the review and submit it. So that's the functionality that we will have at the end of the 4 weeks. And then you can build on that, and I'll give you some guidelines as to what I might be looking for in terms of how you might expand it further. Okay, so that's the lab which you are going to, or sorry, that's the app which you're going to start to build in this week's lab. So let's start the lecture. So we want to dig a little bit deeper into this component idea, because, as I said, our components are fairly simple in this so far. They're completely static. Okay, they're reasonably adaptable through the medium of props. But other than that, they're fairly straightforward. But obviously, there's a lot more to the React model itself, and we'll cover some of that today. Specifically, I want to look at the notion of component state, and it's this idea of state is what's going to make a component dynamic and interactive, and that opens up a lot of doors for us. Consequently, we're going to look at how data flows within an entire app, and we now know that an app consists of a hierarchy of components. Turns out that data flow is pretty straightforward, really, but that was a kind of conscious decision made by the React design team. By simplifying the data flow patterns, it made it easier to debug React apps. Okay, there were some restrictions as a consequence of the data flow patterns that React supports and does not support, but the overall consequence of the data flow patterns that are available to us, which are limited, are advantageous to us as developers, as we'll see. Then we'll talk about this idea of hooks, which is a concept that was introduced reasonably recently in the React time span. They were only introduced in 2019, but React goes back as far as 2013, I think was when it was open source first. So they're a reasonably new part of the React programming model. So we need to discuss them. And the final thing I want to touch on just briefly is this notion of the virtual DOM. Okay. We know what the DOM is in relation to the browser itself. It's part of the browser's own internal infrastructure. React, as it turns out, also maintains a kind of a copy of the browser's DOM itself. But we'll talk about that further down the line. So the first thing is this notion of component state. State always refers to data in programming, as we know. So it's got something to do with the data side of a component. And I'm saying here that a component has two sources of data. We've seen one of them already, which is props. And we know that props are passed into a component, and they're actually going to be passed into a component from its parent. Also, props are immutable. When a component receives props, it cannot mutate them or change them. The second aspect of a component's data is this thing called state. And I often say that state is everything that props aren't, and kind of vice versa. So state is data that's maintained internally by a component. So it's kind of private, if you like, to a component. It can be mutated, it can be changed. And critically, if you change a component's state, then that component re-renders or re-executes. Now, a component, as we know, is just a function. So if a component does have state, many components don't, but if a component does have state, and there is some piece of code within the component, within the component function, that changes one of its state variables, then what React does immediately is it re-executes that component function all over again. And possibly the re-execution may result in the JSX that the component generates to change, and hence the component is dynamic. So this state idea is central to adding dynamics to our components and to our apps. Now, I'm not saying it here, but of course, a component can also have just simple local variables, which, okay, that's data as well, but state and local variables are quite different in how we declare them and how they affect the component. And I've just explained the effect of changing a state part of a component's data. Whether it be props or state, they can be of any type. So they could be primitives, arrays, objects, and typically, a component may receive more than one prop. Equally, it may have more than one part to its state data. Now, just go back to props from last week. I could have covered this last week, but I didn't. Just trying to build it up gradually, really. But props, you can actually, if you want to, declare default values for props. And what that would allow us to do is to call a component or use a component without passing in any props explicitly. But if we have defined default props for that component, then those default values will kick in. So in a sense, our component won't crash just because they haven't been passed in props explicitly. You can also programmatically do some type checking on props. So if a prop is supposed to be an array of integers and somebody tries to pass in instead for that prop an object with a particular shape, then we'd like somehow to be told before we start deploying our app that really this component has been invoked with the incorrect type of props and it should be corrected. I'll show you how to do these things programmatically, but to be honest, I don't apply them at all throughout the rest of this module, and lots of articles that I read about React and look at React code, they're not used either. So they're just one of these parts of the React framework that people didn't adopt in any kind of strict way, but I'll show you how to do them anyway. Going back to state. Okay, state is just data, but it's not ordinary in terms of declaring it. So there is a special way of how you initialize state, and I'll show you in a minute how to do that. And equally, you don't just change a state variable by means of a simple assignment statement. You have to use a special setter method or mutator method to change a state variable's value. But as I've already said, if you do mutate a state variable, then automatically React will re-execute that component function from beginning to end, and possibly what that component generates in terms of the UI may change on the re-execution. So we'll start with a 101 example. So on the right there, I'm showing you kind of a graphical representation of this component that I have, which I've called a counter component. And the way you kind of interpret what I'm trying to get across here now is, in terms of state, this component state consists of a simple integer or numeric variable, if you like, which we are going to initialize to 0. And also this component expects a prop, and the prop I've called jump, and it's also going to be an integer. The component has a button, and when I click the button, what I want to do is I want to change the value of my state variable. So I'm going to have some sort of an event handler within my component that's going to execute when the button is clicked. That's just an ordinary event handling, which we talked about a couple of weeks ago. But the event handler is going to mutate my state variable. And because my state variable has been mutated, this component is going to re-execute all over again. So the actual code for this little component is included in the archive that we were using in last week's lab, and the first of the 2 labs. So if I go back to that archive, which is still this one here, the one that I was looking at there a moment ago, and it's actually sample 6. So maybe if I start up Storybook and just show you the component first. It's not that exciting really, but let's just do it anyway. So if I bring up sample 6, now I do have, as it turns out, I have a number of stories for this, mainly to illustrate one or two other aspects. I think it's other aspects of props rather than state, as it turns out. But for now, anyway, here's my component. Here's my button. And every time I click the button, my component is changing. Okay, all that's changing is this is changing every time. But that is still an example of a component that is dynamic. It's changing as a result of some user interaction. Now, in my case, what the component is doing is it's displaying the current value of the counter, and it's also actually displaying the value of the jump prop that was passed into it. So let's look at the code for this component. We know the nature of the prop that's passed into it, and we know the nature of its state variable. But let's see how we actually declare the state variable. So in terms of state, here's the key line. This is how we declare a state variable. We use a special function called useState, which is, you can see here, we've imported it at the top. The useState is just a function, and the parameter we pass to it is the initial value we want to give to that state variable. So because we're passing it an integer, obviously we can conclude that this state variable, its type, if you like, it's an integer type. What the useState returns is an array, a two-element array. The first element in the array is the current value of the state variable. The second element in the array is a setter method, which we can use within our component if we want to change the value of the state variable. So this is our mutator or our setter method. But that's how we declare a state variable. Now, if we just skip over all of that stuff, here's what our component renders, and we've seen that. Here's the button that I'm clicking. Here's the on-click event handler, as kind of assignment, if you like. Okay, this is the first time we've done any kind of event handling, but you could nearly work out from the text as to what it's doing. So it's an event handler specifically related to clicking on the button. And I'm referring to a function. The function is the event handler that I want to execute, which I have declared up here. Now, what does my function do? Lo and behold, it calls the setter method, the state mutator, passing it essentially the new value that it wants to change the state variable to. In my case, I'm taking the current value of the state variable and I'm just adding the jump prop value that was passed into me. Okay. So as well, just to illustrate something, I've just got a console.log embedded in my components code. Now I'm saying that every time a state variable is mutated, then automatically React will re-execute or re-render, as we say. It will re-render my component. What does re-render mean? It means that this function is executed from beginning to end all over again. And so in a way to try and prove that to you that does actually happen, we will see this console.log. And what are we console logging? We're console logging the current value of count, and we're console logging the prop that was passed into us. If I go back to my storybook, and if I open up the developer tools, and I'll just do a manual refresh here. You needn't worry about that error message, but watch what happens here now. So this is this here has been is the first execution, is the result of the first execution of my component, if you like. So this line here is coming from the console.log. And every time I click my button, the console.log is executing every time. So in a way, that's kind of proving to us that because I know that by clicking the button, I'm running my event handler. The event handler is just changing the state variable, but React reacts to that, if you like, by re-executing or re-rendering my component. And in my case, my component, it does change what it displays on the screen, albeit it's only this part here is what's being changed. But the fundamentals are still sufficient to do something much more elaborate than just that. Now, so that's the essence really of component state and this idea of re-rendering a component every time state changes. If I just go into, if I scroll a little bit further down here, this is where I'm implementing the prop default value and the prop type checking. I am showing you an example of it, but I actually don't use it from here on in, but just so that you can see the coding of it is quite long-winded, to be honest. We are using a third-party library called prop types, and it is a very expressive library. So, in this case, okay, my prop is just an integer. So really all this expression is doing is this is the way I've expressed that my prop has to be of type number. This is my default. This is how I declare the default value. And if I look at the stories, I have a couple of stories for this component. I have 3 stories. One is where I don't, sorry, now let's see. Oh yeah. You see here, I don't pass any prop to the component at all, even though it's expecting a jump prop. So in that case, my default value, which I set to 2, that will be applied. And let's see, does that actually, is that what happens? So this is the default story here. And yeah, it looks like it's picking up 2 as the prop. So that's that works for that story. The second story is the kind of normal case where I'm just passing in, I'm passing in a valid prop into my component. So go back and click on that one. Now the prop is 3, and every time I increment my counter, it bumps up by 3. The third one, I'm passing in a prop of high. Sorry, here, yeah. So clearly that's passing in a string, and that's an invalid type, if you like, and hopefully the coding that I showed you there at the bottom of the component, which checks the type. Now, it doesn't actually work in the way you might think it works. So if I first of all show you what happens when I click on that story, and if I start clicking on my button, and this is one of the quirks, one of the many quirks of JavaScript. If I click on my button, that's what's actually happening. So it's doing string concatenation. So it's not, so the purpose of the type checking prop, the type checking of your props in your code, really the only purpose that will fill is it will give you an error. It'll give you kind of a warning message in the console to tell you that you're using an incorrect type of prop for this particular component. So it's more something that you need to identify as you're doing development, and you fix the problem in your development before it ever gets to production. So you can see the error here, or the warning message. And if I do a manual refresh, just to clean it up a little bit, there's the warning message telling you that you need to go back and have a look at your code because you're using a component incorrectly. So that's the role that the type checking of props plays for you. Okay, so this useState function is how we declare a state variable, and you can have a number of invocations of useState within a component, because you may have its entire state may comprise of a number of aspects, and we'll see that happening a little bit later on. The function is referred to as a hook, and there are a number of other hooks that hook functions that come with React, some of which we'll look at as we work our way through this part of the module. The last comment here down the bottom right is just I'm explaining you from a JavaScript point of view, the way we declared default props and prop type checking from a syntax point of view is we were using static function properties. It's just an aspect of React, of JavaScript. Right. Just to go off on a tangent for a moment, we know from one of my earlier lectures that browsers are an event-driven environment, and we've seen there in the counter component one example of triggering events as a result of user interaction and then handling that event within our code by means of event handlers. So React obviously supports that entire programming model, and clearly, your code is going to be running in different types of browsers, so you don't want to have to modify your code depending on the browser that it's running in. The React event handling system is browser agnostic. So technically, what's happening is when I interact with my component, a browser native event is generated, but React will wrap that browser native event inside a kind of a React event, if you like, and the name of the React event is the syntactic event type, if you like. You don't have to really be too concerned about it, but I'm just telling you that it does wrap the native browser event inside a more generic event object, if you like, and that it's that generic event object that is available to your code. And there are obviously slight differences between the native browser event and the synthetic event object structure that's available to you, but you only deal with this one, so you don't need to worry about the native one. In the earlier days of web app development, we did have to concern ourselves with the structure of the browser native event. Also, what I'm saying down here in this table is that the naming convention used by React for the various types of events that can arise within the browser, the naming convention is slightly different from the native event naming convention. So it's essentially it's this camel case is the naming convention used, as opposed to this more snake case that you get within many of the browsers. So that's just by way of background, really. We don't need to concern ourselves with native events at all. So go back to our notion of re-rendering. It's a term that I'll be using repeatedly throughout this part of the module. So re-rendering is nothing other than re-execution of a particular component. And so this is what I'm trying to describe here is the flow that happens now when the user interacts with a component. In my case, it was the counter component. The user clicks the button. On clicking the button, the event handler is executed. That's just part of the browser's programming model. You can have anything you want to inside the event handler function. But in our case, we called the state setter method here. And once that happened, then really React took care of this part here. We had to code this part, but React does this part for us. So that's the essence of component state. And it's, as I said, it opens up a lot of avenues for us. If I move on to data flow next. Now, there's a couple of messages that I want to try and get across from this diagram. So the diagram is notionally representing an app, and it is a hierarchy of components, as I said at the outset of this lecture. So also I'm using a kind of color coding scheme. So any component that's just a white box is my way of representing a stateless component, i.e. a component that doesn't have any internal state. Whereas a box that's colored in this kind of pinky color, that's my way of representing a stateful component. It has some internal state. So my app here, my fictitious app, has two stateful components, and all of the rest are stateless. And as it turns out, that tends to be what you get for a lot of apps. A small minority of your component hierarchy is stateful. The vast majority of your components are stateless. In a later lecture, I will show you how you come up with a component hierarchy, how you decide which component should be stateful and stateless. We'll deal with that at a later stage. The other thing, the other message I want to get across from this is that props can only flow in a downward direction. And so from a data flow perspective and data flow patterns, React only supports unidirectional data flow, where the flow is always downwards. You cannot have props being passed from child to parent. It's always from parent to child. The third message is, so this is a stateful component here, and I've just been saying that if part of its state is mutated, then this component re-renders. But because it has two children, these two children are also going to re-render. During the re-rendering or re-execution of this component as a result of a state change, it's possible that the component is going to, well, it's not possible, it is going to recompute the props that it wants to pass down to its two children. Maybe the values are going to be the exact same, but it is actually going to recompute them and pass them down as two new prop objects to its children. Having received new props, these two are going to re-render as well. And because this re-renders, then the children on the third layer are also all going to re-render. So in effect, whenever this component, which happens to be a stateful component at the top of my hierarchy for this particular example, when that re-renders, each other component or all other components in my hierarchy are going to re-render as well. If I take this one down here, this is also stateful. If it has a state change, typically as a result of the user interacting, then this will re-render, but only its children will re-render. All of the rest of the hierarchy will not re-render. And the other point I want to get across is if we just go back to this one, for example. So there's a state change in this component and it re-renders. But it's possible that in the re-rendering and the recomputation that goes on inside this component, it may actually decide that it does not want to include this component in the re-rendering. So we'll see a little bit later on how we might put a kind of conditional around including a particular component in the parent-child relationship. As we know now, sorry, I should say as well, this relationship here between this kind of arrow is this parent-child relationship that I was talking about at the beginning. It's got nothing to do with inheritance, if you're familiar with inheritance from object-oriented programming. It's just a parent-child relationship. And again, to repeat what I said was that if we looked at the JSX for this component, then it would simply include references to these components within its JSX. That's what we want to imply by this relationship here. But going back to the point about this re-renders or re-executes, And maybe within that re-rendering, there is a condition test around whether this component should be included or not. And let's suppose in that condition test fails, which means this component is not included. And so what happens is this component, we say, is detached from the hierarchy temporarily. In other words, this will pass new props down to this one and it will re-render, but it will not actually include this at all in the re-rendering. So this component, we say, is unmounted from the DOM. And if it's unmounted or detached from the DOM, it means whatever it contributed to the UI is now going to disappear from the UI. And of course, its children are also going to, whatever they contributed to the UI is also going to be removed from the UI. So when a component re-renders, some of its children may actually be detached from the DOM as a result. Maybe later on, there's another re-rendering of this component. And on that re-rendering, this component comes back into the picture again. It's part of the hierarchy. It's part of the kind of active hierarchy. And so whatever it contributed and its children contributed to the UI, that will now reappear on the screen. So this notion of components being detached and reattached to the DOM, what we say in the language of React is that the components are unmounted and remounted to the DOM. And that happens multiple times while the application is running in the browser. It happens as often really as, in our case, this component, as often as it re-renders. So lots of kind of messages that I'm trying to get across there. And on this slide, I'm essentially kind of talking my way through them, or I'm explaining them again all over again. The other point that I made there at the beginning was that a typical React app nearly always finishes up with a small number of stateful components, but a much larger number of stateless. Okay, so that's data flow. So data only flows in one direction, in a downward direction between parent and child components. And that is significant because if I could just go back to the previous slide, I'm just saying here, right, that other single page app frameworks, they supported what was referred to as two-way data binding, which meant data could flow in both directions. Now, the advantage of two-way data binding was that it was much easier for developers to understand the initial flow of control, and was also much easier to develop your apps. But when things started to go wrong, it was more difficult to debug what was the cause of the error, because essentially there was data flowing in multiple directions between the elements that made up your application. And that was really why the React team consciously decided that they were only going to support unidirectional data flow. It does make the kind of initial learning curve associated with React a little bit more difficult. It also makes it more challenging, arguably, to structure your apps. But the long-term benefit is it's easier to debug when things start to go wrong. Okay, that's data flow. Back to this notion of hooks, which we've already had a slight insight to, but I want to cover it in a little bit more detail. So hooks were only introduced in February of 2019. Now, what hooks do for us, I guess the name comes from this idea that you are hooking your component code into the internals of the React engine itself. That's what the basis of the name is coming from. And so whatever hooks do for us today, we could still program that in pre-2019, but the programming model was arguably a bit more clumsy. First of all, we had to actually implement components using classes rather than functions. And there were certain prescribed methods of our React classes that we had to implement to achieve the same effect as these hooks achieve for us. So this notion of component state was always part of the React component model, but the way we implemented state was quite different. Either way, we're stuck with hooks today, and that's the model going forward. So what are hooks? Well, simply they're functions, and we've seen that with the useState hook. Many of the hooks, and there are many of them are higher order functions. In other words, they take a function as an argument or a callback. What do functions do? They perform component state manipulation and lifecycle management. And we see one part of that story. We've seen state manipulation already. The component lifecycle stuff we'll see a little bit as we work our way through other parts of this module. But they are just functions, but they're special, obviously, in terms of what they do and how we use them. There are many of these hooks, and I'm just listing some of them here. useState, we've seen. useEffect, we'll look at in a moment. useContext, we'll see later on. useRef, I don't think I use it all, actually. And you'll notice that they all begin with the prefix use. And the reason for that is these hook functions, there are restrictions or conditions under which you can use them or should use them. And so if you misuse them, you'd like to be kind of warned about the misuse of a hook before you actually deploy your React app into production. And so there are linting tools. A linter, as you may know, a linter is a tool that will statically analyze your code for weaknesses in your code or errors in your code, because as we know, JavaScript code is not compiled, so we don't have the luxury of a compiler to do this kind of checking for us. Instead, in the JavaScript world, we use a linter. And so these linting tools, they come with rules, and the React framework provides linting rules specifically for checking the use of hooks within our code. So essentially these linting rules, if they see any function call that begins with use, then it knows that that particular function call relates to a React hook. And then it checks to see, well, are you using the React hook as is prescribed by the framework? And okay, essentially there's one primary rule that you have to obey when you're using these hooks. And it is, what I'm saying here is you can only invoke a hook, I'm saying, at the top level of a component function. In other words, you cannot invoke a hook function, let's say, within the body of an if statement, or within the body of a case switch statement, or the body of a loop construct. That's not allowed. So if you try to do that, you'll get a linting error straight away. You can only invoke it at the top level within a component itself. So we've seen the useState hook, and it's by far and away the first hook that you always come across, and it's the one that you will always be using no matter what kind of React app you're developing. You will have a reason to use the useState hook. Some of the other hooks, maybe not. The second one that is most commonly used is the useEffect hook. And you use the useEffect hook if you want a component to perform a side effect. Now, you might remember I mentioned this notion of side effect. A JavaScript function has a side effect if it tries to access or manipulate something outside of its scope. If you remember, that was my kind of loose definition of what I meant by a side effect. Well, in relation to React components, quite often they want to perform a side effect as well. Now, obviously, the nature of the side effects when it comes to React components are specific to web apps. But in general, the use effect hook has more general kind of uses as well. But in the cases where we will use the use effect hook, it will be specifically in the context of the fact that my JavaScript code is running inside a browser. And in that sense, the most common side effect that a component might want to have is it may want to communicate with an external web API. In other words, make a HTTP request to a web API, be it to request data or to send data to the web API. But either way, this idea of communicating with a web API would constitute a side effect. And so if we want a component to do that, we have got to use the use effect hook to program that part of the component. Also, I'm saying a kind of common a common use case for this use effect hook is if you want to subscribe to a particular kind of browser event. For example, if the resizing of the browser window, if you want what's displayed on your app to change depending on the size of the browser window, then your component, some component or components would subscribe to that browser event, and you would program that inside this use effect hook function. So we'll obviously see lots of examples of the first one, and we won't see the second one, but I will show you another typical use case for the use effect hook, other than just making web API calls. Now, the use effect hook itself, it doesn't actually return anything, unlike the use state hook. It returns very useful artifacts to us, but the use effect hook doesn't. But what we pass to the use effect hook is what is significant. We pass it a callback, so it's a higher order function. And we also pass it something called a dependency array. The callback is where we put the code that carries out the side effect for us. So in the case of making a web API call, it's the callback would contain the web API, in other words, the fetch function invocation. The idea of the dependency array is it's going to be an array with references to other variables within our component, whether those be prop variables, state variables, or just ordinary local variables. And the purpose of the role of this dependency array is the entries in the dependency array, they control how frequently your use effect hook is executed. Essentially, anytime an entry within the dependency array changes, then the use effect hook is triggered as a result. And so the use effect I'm saying here is executed. Well, it's always executed when the component is mounted. I used this verb mounting earlier on. Whenever the component is attached to the DOM, which it would be initially when the app is loaded into the browser. But as I was telling you earlier on, during the runtime of an app within a browser, during a runtime session, a component may be unmounted and remounted many times. Every time it's remounted, the use effect hook is executed as well. But obviously, it's also executed when the component is mounted initially. So that always happens. Number two then is, well, when are the other occasions when the use effect hook is executed? And as I was saying there a moment ago, it will be executed every time the component re-renders, provided one of the entries in the dependency array has changed since the previous re-rendering. So there is a condition on it. It's not that the use effect hook is executed every time a component re-renders. It will only execute on a re-rendering if one of the entries in the dependency array has changed. And React will take care of doing that check for you. You don't have to have any kind of code which checks to see has anything changed in the dependency array. That's part of the role of the React framework itself. In many cases, our dependency array is empty. And so if you give the use effect hook an empty dependency array, you should give it something though. You should never give it null, or just not give it the second argument at all. If you give it an empty dependency array, then simply the use effect hook is executed at mount time, and it's never executed on any re-rendering of the component. So to give you a working example of this, which is really what we always need to clarify things. So I've got this little app. Now, in this app, we are using this open API called the Random User API. It's a very simple little API, which if you send it HTTP GET requests, it will return an array of randomly generated user profiles, which I am using these user profiles notionally as profiles of my friends, Maria. And so on the bottom of this slide, I'm showing you how you would communicate with this API. So if we send it, for example, this simple HTTP GET request here, and at the end of the URL, the results query string is how you specify how many profiles you want. So in this case, I'm requesting 10 user profiles. Now, earlier on, I just sent a request to the API, just show you the structure of the response that you get back. So this one here, you can see I sent it a request for just one user profile. And the profile itself begins, let's see, begins here and goes all the way down to, you can examine this later on yourself, goes all the way down to here. So that's one user profile. Now we're only using some of the data in the profile for the purpose of our app. So that request is just for one user profile. If I request, let's say 10, then, just get an array of 10 profiles. Alternatively, you could use the Postman tool. I think you may have used Postman with Eamon in the lecture in his module. And you can see here down at the bottom, the actual structure of a user profile object itself. Go. So the random user web API will return an array of user profiles to us. And so I'm displaying some of my users that will return to me, and I have a little text box here. And whenever I type something into the text box, the result of typing something into the text box will cause this list to be filtered. Okay, so the code for this is available. If you grab this archive here and download it and unzip it, so on unzipping, what you'll get is this folder. Now, don't import that into VS Code. If you just drill down into it, there are two apps. And right now we want to look at this one here. And so if we just run it first, obviously you run npm install first. And then having done that, it's a Vite-based project. So we go npm on dev. So I think I've asked it for whatever, 6 or 10 user profiles. These are the ones that are returned to me. And as I type into the text box, it filters based on the person's second name. So if I go let's say, okay, so that's the behavior. So grabbing the list of user profiles is obviously performed by my use effect hook. The text box and the entering something into the text box. The text box content is going to be a state variable as well, just by the way. But I guess if we just look at before we look at the code, if I just talk about, here's the design for this app, and don't worry about how I came up with the design. We'll deal with that a little bit later on. But from a design point of view, my app consists of 3 components. This is my hierarchy. The top component is the one that we're really interested in. It's a stateful component, and there's going to be 3 parts to its state. These other 2 are stateless. On the right, I'm showing you what the UI looks like for this app. And also, I'm showing you kind of the relationship between a component and what that component contributes to the UI. So if we go from the bottom of the hierarchy and work our way up, the friend component, that's going to be responsible for rendering one friend entry, if you like. This middle component, which I've called filtered friends list, it's going to be responsible for rendering the list of, it's actually the list of matching friends, depending on what's entered into the text box, which could be the full list of friends if the text box is empty. And this component at the top, then, it kind of takes care of everything. It renders the heading, it takes care of the text box, and it also takes care of passing down an array of friends or user profiles down to this component. So presumably this component maps over the array of user profiles that have been passed into it, and that causes it to, and then it instantiates a friend component instance for each friend that it wants to have displayed on the screen. So these 2 components aren't that interesting. The really interesting one is this, because there's a lot happening in it from a state management point of view and also from a side effects perspective. And I'm saying down here at the bottom right, bottom left, that the Friends app component, the one at the top, it manages this app's entire state. It also fetches the API data, and essentially it coordinates the other components in the app. And also this idea, just in passing, this idea of having boxes, the way I'm drawing boxes inside boxes, is a design technique that I will talk about a little bit later on. So we can tell really from the way I've put boxes inside boxes is that this component here is going to be a child of this component, and this component is going to be a child of that component, and that is what we have on the left. But as I've already said, let's not worry about how I came up with the design, although we just need to understand the design. So let's look at the code parts of it. And if we take the easier parts first, which is, let's say, the friend component, what that component is passed in is one user profile object. And so, it's pretty straightforward, really. Just renders one entry in my list of friends. It's not stateful, it's stateless. The component in the middle of my hierarchy, what it receives is an array of user profiles. And as we've seen before, what it does is it maps over the array of friends and generates a friend instance for each one. So we've seen that technique or that pattern already. Just want to collapse that there, sorry. So that's straightforward as well. And here's the important component. This is the one at the very top of my hierarchy. So from a state point of view, I have this state variable, which essentially manages the contents of the text box. Every time the text box changes, I essentially need to recompute the list of matching friends. So that's one state variable anyway. My second state variable, which you probably wouldn't have guessed really, the state variable is going to hold the full list of friends that have been returned from the web API. And I've initialized that to an empty array initially. And I've initialized this into an empty string. Here's my use effect hook. And here's the callback that I'm passing to the hook. Here's the dependency array, which is an empty array. So I only want this hook to run when my when my app mounts or is loaded into the browser, and I never want it to execute again, which makes sense. I only want to call the web API at the very beginning, and I don't want to call it again. But inside in the callback is where I'm communicating with the web API using the fetch function, which we've seen before. And if we just go down a couple of lines, here's the body of my fetch function. In other words, here's the code that I want to execute when eventually I get a response back from the web API. And the response is going to be my array of user profiles. And lo and behold, I'm calling one of my setter methods. Specifically, I'm calling this setter method up here. So when eventually the API returns back with the data, I change one of my state variables, and we now know that that's going to cause my component to re-render. In the rest of this component, what I'm doing with this code here is the event handler associated with the text box. And all it does is it changes the state variable that's managing the contents of the text box. In other words, the first state variable, the top there. Also, what's happening here is I'm just computing the list of matching friends. So I have my full list of friends, which I'm storing here. And here I'm computing the list of matching friends by simply using the contents of the text box and using that within my filter function. I've also decided to lowercase everything just to avoid any case sensitivity. And I'm only filtering on the basis of the user's last name, just an arbitrary decision. So this variable here is going to have an array of friends or user profiles, and it's that array that we pass down to my filtered friends component, as you can see here. So, okay, this is the component that just maps over the array of profiles that have been sent down to it. But the array that we send down to it is the array that we have computed, not the full list of friends. Initially, it will be the full list of friends because the first time, once we have received the full list of profiles from the web API, assuming my text box is still empty, then this is going to correspond to my full list of friends, and that's what I pass down, and that's what's rendered initially. I've also, for convenience, I've got a few console.logs to explain something a little bit in a while. I've got a console.log inside in my use effect, and I've got a console log here. And I've also got console.logs inside in the other two components, the friend component and the filtered friends component. So some points that you need to be aware of. One is that the use effect itself, it runs, I'm saying, at the end of a component's mount process. So the Friends app, that component at the top of my hierarchy, that will have rendered or executed once before the use effect hook callback is actually executed, which means that the first rendering of my Friends app component happens before I've got any user profiles available to me. And we need to be aware of that. And we need to program our Friends app component so that, you know, it doesn't crash the very first time it renders. It's a fairly common issue whenever you're retrieving data and the data is being retrieved asynchronously. You've got to accommodate the fact that you may not have the data available to you on the first rendering of your component, which is the case in this example. Now, what I'm showing you here is I've opened up my developer tools, and what we're seeing are the console.logs that are appearing as my component is executing, if you like. So, and I showed you the console.logs in the Friends app component there a moment ago. So this console.log happens on the first rendering. So that corresponds to console.log that I've just highlighted here. So that's okay. So the component has rendered once already. This console.log is coming from my use effect. If I go back, it's this console.log here. So even though this console.log kind of sequentially, it appears before the other console.log in the code flow, if you like, but at runtime, they execute in a different order. And that's the point that I'm trying to make, that the use effect hook is executed for the first time after its associated component has rendered for the first time. And so I've kind of proven that, if you like, by looking at the sequence in which the console.logs happen here. Why does this console.log happen? Well, the use effect hook, we know what it does. It makes the web API call. Eventually, the data returns back from from the random user web API. And I showed you that in the use effect hook, when we receive that data, we change one of our state variables, which means our component re-renders. And this console.log is appearing because of that re-rendering. Then I say, let's supposing I type something into my text box. Typing something into the text box triggers the execution of my event handler. My event handler, as you might remember, here's the event handler. It also performs a state change, which is why we got this console.log happening. So you can play with that yourselves in your own time. So I'm reiterating the point here that, well, it's kind of linked to it's the use effect hook, but it's also because our use effect hook happens to be making an asynchronous API call. Not every use effect hook does, but in our case it is. And we know that's an asynchronous communication. So we need to allow for that. What we want to ensure is that, you know, the UI mustn't kind of freeze while we're waiting for the data to come back. Potentially, the user might still want to interact. In general now, the user might want to interact with our app while the app is still waiting for data. It doesn't make any sense in the context of our little sample app, but in general, it might be the case where the user might still like to interact with our app, even though the app is waiting for certain data to arrive back from some web API. So what we don't want to have is, we don't want to freeze up the UI of our app until that data arrives. We need to allow the user to interact with the UI. So in other words, components must be still available for re-rendering and displaying content on the screen. Also, we don't want, number 2 is, we always need to be aware of the fact that a component's data may not be available to it when that component wants to re-render. And again, we shouldn't prevent the component from rendering or re-rendering. We need to build it into our code that it can still render even though certain data that it depends on is not available to it. Now, what does all that mean in the context of our simple app? I'm saying that by initializing the state variable that's holding on to, or that's storing the list of user profiles, by initializing it to an empty array, then our app is going to behave normally. In other words, it won't crash. Whereas if we just decided, look, sure, why don't we just initialize that particular state variable to null because there is no data available, that decision would actually cause our application to crash. How come? Because if we look at the component, for every rendering of this component, including the very first rendering, when data is not going to be available to it, it's still going to try and execute this here. So it's still going to invoke filter on this variable. Now, I've initialized that variable to an empty array, so filtering over an empty array is fine. That's not going to cause any issues. Simply means that this is going to be an empty array, and that's still okay. If we pass an empty array down to our filtered friends component, that's not going to cause it to crash, because what that component does, as you might remember, is it maps over that array, and mapping over an empty array is fine. Whereas if I change this to null or undefined even, let's change it to null. That now means we're trying to invoke filter on null. And once I save it and go back to my browser, my screen has gone blank. And if I open up my developer tools, I'm getting that error message that I've mentioned to you that everybody gets eventually. In this case, it's arising because I'm trying to invoke filter on null. In this case, admittedly, it's not on undefined, but null and undefined are very kind of closely related. So the message is you just need to accommodate asynchronous behavior, asynchronous communication calls in your components, and just be aware that a component may render, the very first rendering may occur before it's the data it expects is available to it. Now, in the screenshot I have here, I'm just showing you the console logs that are coming from the Friends app component, the one at the very top. And that's kind of proving to us the rendering and re-rendering behavior of that component. But of course, that Friends app component, it has a child component, the filtered friends component, and the filtered friends component, it has children as well. So every time the Friends app component, the one at the top, every time that re-renders, potentially its children and grandchildren render and re-render as well. And that's what I'm showing you here. So what I've done in order to generate this is I went into my other components and I enabled their console.logs. Okay, I just simply enable this, uncommented, and similarly in this component. And so now when I enabled all of those and I played with the app, and open up my developer tools, this is what I get. So take it from the top. We kind of know now how to interpret the first part. This is the very first rendering of the top component. No data available yet, though. This is the use effect hook. Eventually, that comes back with data, which triggered. Sorry, just give me 1 second there. Oh, yeah. No, let's go back again. This is the rendering of the component at the top of my hierarchy. Now, at this stage, I've got an empty array as my list of friends. That empty array is filtered over to produce an empty array as a result. That empty array is passed down to my filtered friends, and that's where it ends really. It doesn't invoke or trigger the rendering of any friend components. So that's that. What's interesting actually is that the use effect hook, which is linked to the top component, that doesn't actually execute until there is a complete rendering of all of the components initially. All of the components in this case was just 2 of them. So that's another interesting point to get from this. You might think that this console.log should appear here, but it doesn't. Anyway, it makes the API call. Eventually, the data returns back from the web API, which means we now have whatever it was. I think I programmed it to return 6 user profiles. So we have 6 user profiles at this stage. Those user profiles are stored in a state variable, which is why this happened. The component at the top re-renders. It filters over that array of friends. There's nothing in the text box yet, though, so that means that it sends down the full list of friends down to the filter friends component. It renders. It maps over that array of user profiles, and so we get a rendering of a friend component for every entry in the array that was passed down to the filtered friends. So all of these components render for the first time. Then I'm saying over here, let's suppose I type something into the text box. Typing something into the text box is changing one of the state variables in the top component of my hierarchy, which is why this happens. Top component re-renders. There's no execution of the fetch side effect now at all. However, it does compute the list of matching friends based on what was entered in the text box, passes that subset of friends down to the filtered friends component. It maps over that array and generates a friend component for each entry. Now, between this list of friend components and the list of friend components up here, it means that some of these components have been unmounted, and as a result, and so they no longer appear on the UI. So that's our first example of components that were initially appearing on the UI, but as a result of a recomputation that went on in one of our components, they're now being excluded, or they're unmounted from the DOM or detached from the DOM, and so they no longer appear on the UI. And then I type something else to filter it further. So that's kind of interesting illustration of this whole re-rendering that goes on behind the scenes when the user interacts with a React app. So for no good reason, I decided to complicate the story. So the complication, and by complication, I mean we kind of add some more state and some more use effect hooks to our code base. The first principles are the same, though. So if you can follow the first principles, and you do need to play around with this app just to make sure you're comfortable with understanding the flow of execution within an app. But the complication that I've added in is, let's suppose I've got this what I call my reset button, and whenever I click that reset button, I want my app to request a new set of friends from the web API, and that new set is it overwrites the previous set that I would have retrieved. Also, in the browser's tab, I want to display the number of matching friends that are being displayed here at any one time. Okay, so from a UI perspective, they are the two changes that I decided to add to my app. From a app design point of view, it's still the exact same design. The additional code, though, is going to appear here. I now have 3 state variables. The 2 that I already had from the previous version of this app. The 3rd state variable is going to essentially kind of record when the user has clicked the reset button. And I've decided just to use a Boolean state variable for that. So this Boolean is going to go from true to false, false to true. And every time it changes, and it doesn't matter whether it changes from true to false or false to true, every time it changes, I want my app to request a new set of friends from the API as a result. But for now, anyway, it's a state variable. From a side effects point of view, I'm going to have 2 side effects. One of the side effects is the one that we had already. The second side effect is the one that's going to update the browser tab or write to the browser's tab. And clearly the browser's tab is outside the scope of any component. So it's appropriate that we should implement that writing to the browser tab implemented inside a use effect hook. Now, the way you get this version of the application working is if you go back to the app that we had, you'll see here I've got an app.jsx and an app2.jsx. And if I go into the index.jsx, which initially was referring to app, if I just change that to app2, and save. And let's just see the behavior first. Just going to close off this for the moment. So clicking my button just gets me a different set of friends every time. Text box works as before. And if you can see here over on the top right, I'm just in the browser's tab, I'm showing how many friends are currently being displayed. So it looks like I'm requesting 10 friends at a time, but if I try and filter them, you can see that the tab has changed. Now, you obviously need to play with this yourselves, but if we just quickly kind of maybe run through the code, obviously a lot of it is the same as before. What's new is, here's my 3rd state variable. And, I've just arbitrarily decided to initialize it to true. Here's a side effect that we had before. The second side effect is here. And okay, it's old browser type coding, but this is how we write to the browser's tab. And I'm putting that inside a use effect hook because it is a side effect. Now, the other thing that's interesting from the use effect hook perspective is if I scroll up to the first hook, in this case, its dependency array is not the empty array. It contains one variable in my case. Sometimes they contain more than one variable, which is why it's an array rather than just a single variable. I want my component to communicate with the web API every time the user clicks the button, as we know. So if I find the button code, which is here, on clicking the button, I call an event handler. Now, sometimes you can inline. If the event handler is very short, as in if it's just a one-liner, you can actually inline the event handler code within the on-click attribute of the button itself. So that's really all that you're seeing here, right? I've actually this is actually the event handler in its entirety. rather than declaring it separately as a function higher up and somewhere else in my component. I've just inlined it here. And what is the event handler doing? It's changing the state variable, the Boolean state variable. So every time that state, of course, when we change that state variable, the component is going to re-render. But I want my component to communicate with the web API when that happens. And so that's why the dependency array in this case includes the Boolean state variable. Anytime that changes, and we now know it changes every time the user clicks the button, and all it does, if I just go back down to the event handler again, all it does is it just takes the current value and just toggles it. You can see the not there in front of the Boolean reference. So it just toggles it from whatever its current value is to the opposite value. So, but every time it changes, that now means that this side effect is going to execute. And that's really what I want to happen. Also, the other side effect, the one that writes to the browser tab, its dependency array is significant as well. And I'm saying, in this case, it's actually just looking at the length of the array that contains the matching friends, which is this array here. So the entries in the dependency array can refer to anything, can be a prop, can be a state variable. In this case, this is just an ordinary local variable, if you like. It's computed, admittedly, and it's an array in this case, but it's just an ordinary local variable other than that. And so whenever the size of that array changes, then that's when we want to update the browser tab. And so we get the way we achieve that is by A, putting the code that changes the browser tab inside a use effect hook, and B, using the length of the array as my dependency array entry for that use effect hook. So it's quite complicated, I'd have to admit now, but you just need to play with it to ensure that you understand the full flow of control. So there's lots of state variables that are changing, and the user effect hooks are being re-executed sometimes and being ignored other times. And what I tried to do by virtue of this, by virtue of this screenshot here, again, there were console.logs scattered inside my code. So the console.logs that we see here are just limited to the Friends app component. And again, you'll see I've got a console.log inside each of my use effects. And I've got a console.log for the component itself, which will output every time the component re-renders. The other console.logs only appear when that use effect is actually executed. And, you know, it's not easy to talk your way through these things. It's you really get it from playing with it yourself, but I'll try anyway. So again, the Friends app component renders at the very beginning. We've no friends yet. The use effect that fetches the API data executes, and the use effect that writes to the browser tab executes. This is going to write the fact that there are no matching friends currently being displayed. This is going to make the API call. Eventually, the API call returns back, and we update the related state variable, which is why the component re-renders again. It recomputes the list of matching friends. That means my browser tab needs to be updated, which is why this console.log happens. Then the user comes along and types something into the text box. That changes one of my state variables. So the Friends app component re-renders. Presumably the list of matching friends is going to be smaller than what was being displayed. It's recomputed anyway. Let's assuming that it's a smaller list. So the side effect that updates the browser tab needs to execute, and that's confirmed here. The user clicks the reset button, I'm saying, is the next thing that happens. That changes one of my state variables. Friends app component re-renders. The use effect that makes the API call, it's going to execute because the state variable that has just been changed is in the dependency array of that use effect hook, which is why this happens. The component re-renders eventually, again, as in the API data, the API will respond with the new list of friends. Those new list of friends are entered into one of my state variables, which is why the component re-renders yet again. Presumably, I now have more friends being displayed than there was previously, which is why the use effect that updates the browser tab needs to execute, and on it goes. So really, as I've kind of said once or twice already, you do need to play with this app yourselves. I have purposefully disabled the other console.logs in the other components, just for clarity, really, because otherwise they'd start appearing here all over the place and I wouldn't be able to squeeze it all into one screenshot. And here is the confirmation of everything that I've said, so you can read through that yourselves. Right, that's heavy going, admittedly, but there you go. So we've looked at two hooks, useState and useEffect. And I would argue that they are the more complicated of the other hooks that we look at. We look at about maybe three other ones, but really the two that we've looked at are all about, they're central really to the whole dynamics of how a React app works. And so all that's really going to happen is that, okay, our apps are going to have more components than the three app component or the three component app that we've just been looking at, but the first principles are still the same. So it's kind of important that you play around with that sample app that I've given you, because it's as simple an app as I could come up with, but still we get to see those two hooks, how they behave and how they influence the runtime behavior of your React app. I'm going back to data flow because it turns out that there is actually a second data flow pattern that React supports, and it's one that we will see quite a lot. So not only do we have this unidirectional data flow, but we have what's also, it's got two names. It's got the data down, action up pattern. It's also referred to as the inverse data flow. I don't like the second name because that kind of suggests that inverse data flow kind of suggests that data is flowing in an upward direction, and that is not what we're trying to explain here. It's very different from that. So data down, action up, I think, is a more accurate name for this pattern. And to say that it's a data flow pattern is kind of questionable as well. But either way, it's a pattern that we do see a lot. Now, where it arises is, I'm saying often a component's state is changed as a result of an event that happens in a subordinate component. Up to now, the Friends app component, if you like, its state changed as a result of an event that occurred within the bounds of that component itself. So it was kind of local to the component. But often it will be the case that it's a subordinate component and an event associated with that subordinate component. That is what will trigger or should trigger the changing of our stateful component's internal state. So how do we deal with that situation? And the answer is, okay, we implement this data down, action up pattern. Now, rather than coming up with yet another application to illustrate this, I'm going to stay with the same application, but I'm going to redesign it. And the redesign is going to come in the form of, I'm going to put the text box and the management of the text box and the rendering of the text box, I'm going to put that in a separate component of its own, which means our component hierarchy now looks like this. So this is the new component, and its only purpose is to manage the text box, as I said. But from an event and state change perspective, this is still my stateful component. But it's the entering of when I enter text on the text box, the event that is fired by the browser is now associated with this component here, though. So how does it tell this component, you need to change your state variable? And the way it works is by means of props. What this component is going to do is it will essentially have a function which will change the state variable, but it's going to pass that function or a reference to that function as a prop down to this component. So up to now, I've said that props are a way of transmitting data between parent and child. Well, it's actually broader than that. A prop can also refer to a function. And so in this case, we will be passing a function reference through the medium of a prop down to this component. And so when the event occurs and the user enters something in the text box, the event handler code will be inside in this component. But in the event handler, it will invoke the prop function that was passed to it, which means effectively it's invoking a function that's declared up here. And the function in this case is going to change the local state variable, and the whole re-rendering stuff happens all over again as usual. So all I'm going to show you is excerpts from the code. I'm not going to step my way through the code. The code itself is contained inside in the second folder of the archive that we've downloaded. So it's a completely separate project, if you like. And here are some excerpts from the code. Again, the general idea is you've got a stateful component, and it provides a callback for the subordinate, and the subordinate invokes that callback at the appropriate time. Here's an excerpt from my friend's app component, the one at the top of the hierarchy. And so if we pay attention to this here, this is just an ordinary function, but it is performing a state change or mutation. We pass this function down as a prop to a subordinate. In this case, the subordinate is the component that's managing the text box. Here is the subordinate component. It's very simple in this case. So it just has in terms of JSX, it just has the text box itself down here. It has the onChange event handler. Where are we? Here we go. The onChange event handler. This is referring to a local function, which it has to. But inside in the event handler, at the very end of it, we're invoking the prop function that was passed down to us. So effectively, when this line here executes, it's effectively invoking the function that's declared up in the parent component. And that does what it does. And so if you like, the name of the pattern, data down, action up, data is always being passed in a downward direction. Now, there is no data being passed to my search box component in this case. But the action up idea is that actions are flowing in the upward direction, as in we're invoking functions in a kind of an upward direction rather than the downward direction. That's where the name comes from. And as I said, it is a pattern that we will see being used quite a lot. The last thing I want to talk about is something called the virtual DOM. Now, we know what the DOM is from a few weeks back. It's this data structure that's always been in the browser, way back to the days of the static web. And we know what its role is. Now, the thing is, though, that in the early days of dynamic web apps, it was up to the developer to be aware of how they should manipulate the DOM data structure. And over time, there were good practices and bad practices associated with DOM manipulation. And if as a developer, you weren't aware of what was good practice and bad practice, then it could affect the performance of your app. By performance, I mean, there'd be latency in how the UI changed as the user interacted with the app. So, the developers had to build up knowledge, and I'm just mentioning some of the things here, like, you shouldn't manipulate DOM nodes when they're currently attached to the DOM. You should detach them, manipulate them, and then reattach them, and lots of other things as well. So, like I said, it was up to developers to actually acquire that knowledge. And so what the React design team kind of asked themselves was, should we still leave that responsibility on the developers' shoulders? And they decided no, that they should try and somehow incorporate good practices into the React runtime engine itself and relieve the developer of any of that responsibility. And so the mechanism that they came up with to achieve that was something called the virtual DOM. And what the virtual DOM is a much more lightweight and efficient data structure mirror of the real DOM being what the browser actually maintains. So the browser maintains the real DOM, the React engine maintains a copy of that, but it's a much more efficient copy called the virtual DOM. And so this is kind of how a React works kind of behind the scenes. So you go in, write components, and you have a component hierarchy. And as we were talking about there, components are rendering and re-rendering. Whenever components render and re-render or mount and unmount, what's actually happening is the virtual DOM, the React engine is updating the virtual DOM structure to reflect the changes that are happening in your code. So initially, what it does is it creates an initial version of the virtual DOM. So when the app loads into the browser initially, it has to let the browser create the initial DOM structure. And once that's created, then React steps in and makes a copy of it, which we call the virtual DOM data structure. Then your React code is changing that virtual DOM structure, or the React engine is changing it on your behalf. And so now every time the app goes through a re-rendering phase, what it will do is it will make a copy of the virtual DOM, make the necessary changes to the copy of the virtual DOM based on what components have changed and what new components have mounted and what components have unmounted. So it now has two copies of the virtual DOM, the new one and the previous one. It then carries out a diff operation between the new one and the previous one. That diffing operation will tell it what changes actually have to be carried out on the real DOM. And then it will do a batch update on the real DOM. And as before, once the real DOM is changed, then the browser kicks in and reflects that change on the screen. You could quite happily, and I do, program in React and not really care about the virtual DOM. I'm just making you aware of this is what is happening behind the scenes. And you may get error messages every now and again referring to something called the virtual DOM, or you may read an article about it, or it comes up in an article about React. So that's kind of where it's coming from. Now, there are newer generations of single-page app frameworks which have discarded the virtual DOM idea. It was a dominant idea for a number of years, and a number of frameworks copied it. Now there are actually a generation that are discarding it, but we'll see how things turn out. It's all about making you see, the consequence of this virtual DOM existing is our programming model is much simpler than it would be if we actually had to program the real DOM manipulation ourselves. That's one of the reasons behind it. The other reasons behind it was that it would make your app performance better. And so, you know, if we go back to our simple little counter example, if you remember, we had a button, we clicked on the button and it updated a counter. So this is what's happening really behind the scenes. Like the user clicks the button had an on-click handler, the on-click event handler executed. That's the on-click event handler, if you remember, caused a state change. So the component state changes. And then this is what React does behind the scenes. It now kind of re-executes the component. That re-execution is going to make a change to the virtual DOM. It then does a diff between the new virtual DOM and the previous one, as I kind of said, and it batch updates the real DOM. Or if we take the application that we've been looking at there, the one that with the text box, you know, this is a more detailed explanation as to what's happening behind the scenes. So the user enters something on the text box. The text box had an event handler associated with it. The event handler triggered a state change. And so again, React re-renders the Friends app component. It re-renders any children of the Friends app component and any grandchildren, if you like, and keeps on going. So once it has re-rendered the Friends app component and all of its children, which is essentially the entire app, everything is re-rendered now. So it now has a fully updated virtual DOM. And it, what am I saying here? React re-renders. Okay, that's all right. It then goes into what in React terms we call the pre-commit phase. This is where it determines what changes need to be made to the real DOM. It then commits those changes to the real DOM, which in React terminology is called the commit phase. And that's React done at that stage. It has done its job. It has updated the real DOM. Then the browser does this part as before, just goes through its flow phase and its paint phase, if you remember. Okay, I'm not going to talk over this slide. It's just summarizing, but it's all about hooks, use state and use effect. There are a few other hooks that we will look at a little bit later on. Arguably, the use state and use effect are the trickiest one to kind of get your head around, and they are core to React and how it works. So if I were you, I would strongly recommend that you spend a bit of time playing with the first of the two apps that I've talked my way through there. You know, enable all of the console.logs that I've put into the code and, you know, try to simulate the screenshots that I showed you and all the re-renderings that are happening as you interact with it, and get a full understanding of what's happening behind the scenes. That would be very worthwhile because that will help you later on in any kind of debugging that you may need to do.